Hey folks, I'm back for part 2 of my exam review lecture. So I'll pick up where I left off. I was actually talking about map projections, but before I do, I'll return to the exam review and study guide document. Went through and talked a little bit about the various coordinate systems and grid systems. You'll notice down at the bottom that you want to be able to determine latitude and longitude, UTM, and state plane coordinates off of a topo map. And also the public land survey, to be able to determine the public land survey description off of the topo map. All right, so in terms of projections, I guess I'll start sort of where I left off, in terms of these two basic pieces of information, the developable surfaces that are used to generate a map projection. 3 of them are shapes. The first is a plane. We use the term planar or azimuthal. The second is a cone. The third is a cylinder. And so those are essentially shapes, and one of the things you want to be aware of is that the contact point of the shape will end up being the area of highest accuracy, and this will often be a central meridian or a standard parallel, and that's again where you're going to see the least amount of distortion. So you can get that either by, well, with a plane you're looking at a point of contact versus a cone or a cylinder, and mathematical models are kind of a different category. And then these different 4 classes that are based on the preserved property. I will say that this is a very complicated topic and one that I'm not going to spend a lot of time on the exam with, so you should recognize these general distinctions, but don't concern yourself too much with being able to use different projections. You won't be asked to do that in ArcMap the way that you were in lab, and will not be a significant part of the exam. Okay, so scale. First of all, when we're working with scale, remember this idea of a scale factor, which is written as a ratio. These do not have any units associated with them. You should recognize the distinction between a small scale map and a large scale map, which can be confusing because we see a map that covers the whole world and we immediately think large scale, but actually that's a small scale map because there's not much detail. And when you see the large number on that will again be somewhat confusing because you think, oh, okay, that's a large scale, but actually when you read this ratio, if you think of it as a fraction, like 1/3,000,000th, you realize that's a very small number, a much smaller number than, say, 1/2000th, if you put that as a fraction. So that's a good way to remember that. I mentioned, being able to use the ratio to determine a distance. So map units to ground units, the example I was giving before I got cut off on the last lecture, but again, relatively small part of the overall exam. So I think if you review that example, you should be okay for that problem. Scale bar, again, be able to use the scale bar to measure distances. And again, the best way to do that, students tend to want to use a ruler, but a ruler can be somewhat confusing because you're measuring the distance on the ruler and then you have to convert that from the scale bar, whereas really all you're trying to do is determine the distance between 2 points. I like to use just a blank piece of paper, mark the distance, and then just transpose that down to the scale bar and determine what the distance is from the scale bar. Pretty easy way to do it. Again, mentioned direction and orientation, cardinal directions, true north, magnetic north, and grid north. Not emphasizing the grid north very much, but you do want to understand the distinction between true north and magnetic north. and the role of magnetic declination in relation to magnetic north and true north. Magnetic declination literally is the difference between magnetic north and true north for a specific location. And what you want to realize is that the magnetic declination will be different in California than it will be in Colorado, than it will be in Kansas, than it will be in Virginia. Okay, so it varies because the relationship between the north and the magnetic poles vary as you move from location to location, and the magnetic north pole changes location over time as the Earth's magnetic field changes. Alright, so azimuth bearings, quadrant bearings, being able to convert between those two, being able to determine azimuth bearings using a compass in the field. I do have compasses in my office if anybody wants to come in early and practice their compass skills. And then relief portrayal. This is a subject that we addressed last week, and I don't have a whole lot of detail listed here. You should recognize the difference between contours as a method of representing relief portrayal and what contours are, how they show equal lines of elevation. I won't ask you to interpret contour lines on a map on this exam, but you should understand that there is an even spacing between contours. For example, what's called a contour interval. Shaded relief, of course, something that we're all familiar with in the modern maps that we look at today, and the role of digital elevation models in creating that. Okay, so let me jump back over to my PowerPoint slides here for a moment. Again, this is sort of where we left off in talking about these map projections. There's your developable surfaces that will be essentially used to project the spherical Earth onto a flat surface. Essentially, with a cone and a cylinder, what you're doing is putting the cone or the cylinder around the Earth and then peeling away the cone or the cylinder to produce a flat map. Again, lots of methods of relief portrayal we're seeing today. This is something you'll see on Google Earth. And in this case, all they've done is taken an elevation model and draped the imagery over the top of it. Kind of a variation on the shaded relief model. Okay, so a little bit about GIS. What does it spell? You know, it's amazing, or not, that this acronym is so often used in a way that people don't understand what the actual acronym refers to. So you should know what GIS stands for. You should understand that GIS uses layers of data. Okay, so we can see that there are photo points and parcel lines and water bodies, points, lines, and polygons divided into layers. That we have spatial features like these parcels, and then the attribute component that goes along with each of the individual spatial or feature components. And understanding some of the essential capabilities of GIS. Again, you're not going to be asked to do this on the exam, but as we look at the section that I have laid out for GIS, I do give you a definition. I do remind you about what GIS stands for. I talk about some of the feature and attributes that we talked about, and I identify some of the essential characteristics or capabilities that we have with GIS. So again, in this sense, you're going to be asked more how you would, generally how it's used, as opposed to being able to apply these skills in practice. You will not be asked to do that, as indicated at the bottom of the study guide. All right, well, I think that pretty much covers the overview that you need for the exam, so I'll leave it at that, and we will see you online and in class tomorrow. Have a nice day.